Hi everyone, this is your math guru. Today we're going to learn the chain rule. Please don't forget to subscribe below for more easy to understand math concepts. The chain rule is usually applied to composite functions, that is when you have one function inside another. The rule states that your dy dx equals dy du times du dx. Let's look at the following examples. Find dy dx when a y equals in bracket x squared minus 2 all to the power of 4. The x squared minus 2 is our inner function and the 4, the exponent, is our outer function. Let u equals our inner function, which is x squared minus 2. From here we know that if we differentiate u with respect to x, we have du over dx equals 2x. We will be substituting that into our chain rule, and because we already said let u equals to x squared minus 2, our y is equal to u to the power of 4. If we differentiate y to u, we are going to have 4u cubed. We are also going to use that for our chain rule. We know that our chain rule is the y over dx equals the y over du times du over dx. Therefore, we have the y over dx equals the y du is 4u cubed times du dx is 2x. If you replace the u with x squared minus 2, we're going to have the y dx equals 4 in bracket x squared minus 2 to the power of 3 times 2x. And if we simplify, we're going to have the y dx equals 8x in bracket x squared minus 2 to the power of 3. Let's try out another example. In this example, we have find dy dx when y equals the square root of x plus 2x squared. We're going to change our square root to rational exponents, and we're going to have y equals in bracket x plus 2x squared all to the power of half. Then the next step, letter u equals x plus 2x squared. I know that my du, the x, is going to give me 1 plus 4x. Slotting back the value of u into the original equation, I have y equals to u to the power of half. And if I differentiate the y with respect to u, I'm going to have half u to the power of minus 1 over 2. If I put all this value for du dx and the y du back into my chain rule, I'm going to have the y dx is going to be equal to the y du, which is my half u to the power of minus half, times du dx, which is in bracket. I'm going to use my bracket because it is an expression. Substituting back the value of u, I'm going to have 1 over 2 in bracket. My u is x plus 2x squared to the power of minus half times 1 plus 4x. And I can leave it this way or put it in positive exponents. I'm going to have the y dx equals in bracket 1 plus 4x over 2 the square root of x plus 2x squared. Let's try out one more example. In this example, I have find dy dx when y equals 1 over in bracket x squared minus 3 all to the power of 3. I'm going to change this into y equals x squared minus 3 minus 3. Taking my bracket to the top, and I have let u equals my inner function, which is x squared minus 3. My du dx from here is going to be 2x. Substituting the value of u into the equation, I'm going to have y equals u to the power of minus 3. And finding the y du, I'm going to have minus 3 u to the power of minus 4. Going back to our chain rule, I have dy dx equals dy du times du dx. And substituting the value of dy du, I have minus 3 u minus 4 times du dx, which is my 2x. Substituting the value of u, I have minus 3 in bracket. My u is x squared minus 3 to the power of minus 4 times 2x. If I substitute further, I'm going to have minus 3 times 2, that's minus 6x in bracket, x squared minus 3 to the power of minus 4. That's my dy dx. And if I want to leave it in positive exponent, I'm going to have dy dx equals minus 6x over, in bracket, x squared minus 3. Let's take a look at the following challenge question. I omitted my power of 4 here. Sorry about that. Let's go back to our challenge question. The first challenge question says, find the y dx when a, y equals 2 in bracket, 3 plus x squared all to the power of 5, and b, y equals 1 over, in bracket, 4x plus 3 all to the power of 2. You can pause the video and try it out yourself. For the first one, you're going to have dy dx equals 20x in bracket, 3 plus x squared all to the power of 4. And the second challenge question, you're going to have dy dx equals minus 8 over, in bracket, 4x plus 3 all to the power of 3. That is if you're leaving it in positive exponent. Thanks for watching. Bye.